Hey guys, welcome back. Pre-Calc Lesson 12.4, more finding limits analytically. Today we're going to talk about complex fractions and piecewise functions. So how do I deal with this situation right here? I want to find the limit as x approaches 0 of 1 over x plus 1 minus 1 all over x. So again, obviously direct substitution will not work because if I try and plug in a 0 here, I get a 0 in that denominator. So how can I clean up this expression so that it gives me something I can use direct substitution with? Well, what we're going to do first is we need to identify the common denominator for all three of these fractions. So obviously, it's going to be x plus 1. And then what I'm going to do is I'm going to multiply all three terms by x plus 1. So what's going to happen here in this first fraction is those will cancel. So that's just going to give me a 1 minus. Now again, you have to be careful here because remember you're subtracting a binomial. So don't forget your parentheses. And all of that's going to be over x times x plus 1. Now again, remember I'm not going to multiply these out because this is the problem area. I want to get rid of the x. So I'm hoping I'm going to have something here that cancels with that x. Well, if we take a look here and distribute this negative, up top, I've got 1 minus x minus 1. Well, that's just going to give me a negative x. And then my denominator, I have x times x plus 1. Well, now what happens is these x's cancel, and my expression is negative 1 over x plus 1. So hopefully that's going to be something that I can now use direct substitution with. So I have the limit as x approaches 0 of that expression. Plug in your 0 now, and I get negative 1 over 0 plus 1, which is just negative 1. So that's how we handle a complex fraction. Let's try one more. So once again, try your direct substitution, but pretty obvious. Plug in a 0 here, that denominator 0, not going to work. So now I look at my denominators. X plus 5, that denominator is a 1, that denominator is a 1. So my LCD is just going to be x plus 5. Multiply all three of these by x plus 5. Do the work, write it out. Now what's going to happen is that denominator will cancel with that. So I've got 10 minus, now you can multiply this out at this point. You can take an additional step, but just be careful with this negative right here. So I'm going to have negative 2 times x, which is a negative 2x. And then I have negative 2 times 5, which is negative 10. And again, my denominator, I'm not going to multiply it out because I'm hoping the x cancels. That is the problem right there. So let's clean up our numerator. This is going to give me a negative 2x, and the 10's cancel. My denominator is x times x plus 5. And this is going to work. X's cancel. I'm just going to be left with a negative 2 over x plus 5. So now I can find this limit. The limit as x approaches 0 of negative 2 over x plus 5. Now I can plug in my 0. Negative 2 over 0 plus 5 is simply negative 2/5. All right, piecewise functions. All right, this is going to be a little bit like that example we did on the second day. The only difference here is you're not going to be given the picture. You have to kind of create it. So we've got piecewise function here. I sort of color-coded it. The first piece is x squared plus 1 from negative infinity to 0. All right, so what's going to happen here is at 0, it's going to change to negative x plus 4 from 0 to 3. And then at 3, it's going to change to 2. So you don't necessarily have to do these in the order that they're given. I usually like to do the easier pieces first. So for me, this piece right here is pretty easy. 2. It's just going to be a horizontal line. So from 3, and notice that's a bracket, so it includes that, to positive infinity, my graph's going to look like that. Okay. Well, the next piece I have here, this is just a linear. It's a line from 0 to 3. Well, the y-intercept is 4, and my slope is a negative 1. Okay, well, let's see, it's green. My y-intercept is 4. Slope is -1. Oh, I got to change that. Notice that's going to be an open circle. Slope's -1 until you get to 3, and that's also going to be an open circle. So you got to be careful there. And now this is going to be a parabola. Pretty straightforward. All I'm doing is shifting it up 1, and that's going to look like this. So up 1, this is going to be a closed circle. Over 1, up 1. Over 2, up 4. Over 3, up 9. It's going to look like this. Now, if you needed to, you could also create an XY chart for each one of those pieces and plug in those points and get that picture. Okay, so now that we have that, finding the limit. So remember, I have to take a look here. Finding the limit of this function as x approaches -1. So as x approaches -1, I have to look to see if we're pointing to the same thing. And we are. Both of those arrows are pointing to 2. So that simply means that this limit is 2. Okay. Same exact problem. I just copied the graph down. New limit, however. Now I want to find the limit as x approaches 0. So I move from the left until the x value approaches 0. So I'm pointing there. And now from the right. So notice how those two arrows are pointing to different values. They're not touching. They're not pointing to each other. So if the arrows point to different values, that means that there is no limit. It does not exist. Because when I have the left-hand limit and a right-hand limit that are different, it does not exist. All right, same graph again. This time we're approaching 1. So let's see. As I approach 1 from the left and 1 from the right, they're pointing to that same value. Well, what is that value? That's 3. So I would say the limit here is 3. Again, why is that? Because the left-hand limit and the right-hand limit point to the same y value. All right, last one. The limit of f of x as x approaches 3. So we're just kind of working our way across this graph. As x approaches 3, notice those two arrows are pointing to different values. So it looks something like this. Since they don't point to the same y value, the limit does not exist. All right, so that concludes this lesson. A little bit shorter. I'm sure you guys are thankful for that. As usual, please email or contact me if you have any questions and do the homework associated with this. Thank you.